Hey everyone, it's Emily with Spiceworks. Thanks for tuning in today and joining us on another Spiceworks Partner webinar. Get all flash performance using Intel SSD and StarWind HyperConverged Appliance, brought to you by StarWind and Intel. Before we get started, I do want to remind everyone this webinar is being recorded. If you have to step away for any reason, you will get an email with a link to the video in about a week. Also, there's a Q&A box on your screen to the left, and I encourage you to submit your questions at any time throughout this presentation. We'll get to those questions at the end via verbal Q&A, but if your question isn't addressed live, someone will be able to follow up with you. Now I'd like to introduce our presenters, Alan Shear, Solutions Architect with Intel, and Max Kolomayedsin, Director of Product Management with StarWind. So Max, whenever you're ready, take it away.
Okay, always ready. Hi everyone, thank you for joining our today's event. And my name is Max, and we'll also hear today from Alan Shear. He is actually a really knowledgeable gentleman working for Intel and developing high-end storage. And he'll tell you much more about it in just a few seconds. And myself, just humble Director of Product Management at StarWind, been here for almost 10 years, so I've seen some storage changes over the time. And you can also find me on Spiceworks, helping out folks who are building their virtualization environment. My posts are marked as Max at StarWind. So with that, I would like to turn it over to Alan. Alan, whenever you're ready.
Well, that was fast. Just so everybody knows, Emily is a lot less animated when she's not on the presentation. I was really surprised there. So a couple things about the agenda today. We want to bust some SSD myths because there are a number of them out there, and that's primarily what I'm here to do, is to talk a little bit about Intel SSDs and our flash and non-volatile products with a view towards not only what we're selling today, but what's going to come out in the future. Why that's important for this particular presentation is StarWind has recently begun issuing a version of their HCA appliance series, which includes the Intel SSD products, and that's a really exciting thing for Intel, and frankly, it ought to be pretty exciting for the end users as well, and that's kind of what I'm here to go into. So let's talk a little bit about Intel and bust some myths along the way about SSDs. This is kind of a slide based upon a lot of research that we've done in-house, where we've looked at both our average failure return rate and our average our failure rate and our average return rate, and I should say annual instead of average. And one of the things that we have is in the flash industry, we have a lot of, I don't know how to put it, a bad reputation is maybe the way to put it, because early flash products did not meet everybody's expectations for reliability. And I think everybody's heard a war story or a horror story based upon that. Part of that reason is that we really didn't understand, or the industry, I should say, did not understand how flash was going to wear and what was really going to go on. So there was a lot of kind of experimentation in the wild there. But what's happened is really today's flash products, and this is actually including everybody. I'm happy to talk up not only Intel, but the entire industry. The average failure rate or the average return rate for hard drives is typically about 2.5% to 5% per year. And that's pretty huge when you think about it. And I've got a little dot up there to kind of a little authority point that says 20 times HDD. And the first thing I want to say is just about everybody's flash products on the market are about 10 times more reliable than your typical hard drive, your spinning at 10K or 15K data center class drive. So flash overall is quite a bit more reliable than it's ever been, and it's more reliable than hard drives in a general sense. Our own data shows that our products are as much as 20 times more reliable than your typical data center class hard drives. So we're really getting failure rates that are approaching zero, and you can kind of see our little graph at the bottom where we're tracking various parts of our non-volatile memory business and how over time we're driving that return rate down even further. That little dotted line, by the way, that was kind of some targets that we set early on in the business, that what we wanted to meet. And even though we were doing really great stuff, we're far below what we wanted, far below where we want to be in terms of average failure rate and average return rate. So that's a really important story, I think, for the industry and for anybody who's considering using flash products in their storage arrays. One of the things that we do that's unique, and this is actually unique to Intel first, is we're very, very big on the concept of making sure that the flash just plain doesn't have a problem in the first place. And one of the little areas that a lot of research has been done by Intel is the area of something called silent errors. Now, silent errors, I could probably do a 3-hour presentation on this, and if you want to copy down that presentation, that blog at the bottom there, I'll be talking enough time that you can do that, or send me an email or something later, and we'll get that link to you. There's an article here that goes in tremendous detail about what the nature of this problem is. And what this is because we are with flash using a technology that essentially traps electrons in little gates. What will happen is cosmic rays, believe it or not, can dislocate those electrons and cause errors that you don't even know occur on the disk. So how do you deal with this problem? It's not caught by things like ECC or parity checks. It's not caught by RAID. This is just plain an area where with flash, the data on your drive, conceivably, if this problem occurs, can alter the data on your disk. Now, if that's a desktop drive, that might mean you have a line through a picture of your favorite cat video or something like that. If it's your corporate data, it could mean that everything about your financials are now completely trash for the year. And you don't see it. Your system does not see it as an error necessarily. It just sees it as data like any other data. So what do we do about it? Well, we make our flash very resilient to this problem, and we've tested it like nobody else has. And if you go into this particular blog article, you'll note that we've been able to verify that our silent error rate is something like 255 times better than our closest competitor in the industry. Part of the reason we've been able to do this is because we actually test it. And we are, to date, as of my knowledge, that's my little disclaimer, the only company to test for this error. And we know that because there are only 2 places in the world that will do this kind of testing for you, and that's Lance or the IU Cyclotron Operations Center. And we do these tests all the time, and we can verify that testing our stuff compared to our closest competitors, you're not going to get this problem with our drives, and you may very well have an issue with some others. Again, this is a problem where it's not corrected for by any kind of RAID or ECC or error correction that's built into the firmware. Matter of fact, sometimes it's actually the firmware that gets affected by these errors. So having a drive that is built from the ground up for reliability against these kinds of problems is a really big issue, and that's one of the reasons why you ought to be excited that StarWind's including that in their flash arrays today. Of course, one of the big things right now is we've moved from SATA to NVMe. I probably shouldn't put it that way. We haven't moved from it to another thing. We haven't dropped SATA. SATA is going to be a big part of the business for a long time to come. But we now are using NVMe, a new protocol that does incredible things in terms of performance, along with being able to do things like, not necessarily just be faster, but it uses less power per gigabyte and all kinds of good stuff like that builds into a nice story about cost of ownership, which is a big concern sometimes. Part of what we can show about that is the following. If you take a look at this little graph here, this isn't one of my favorite slides, but what we can see there at the bottom, if you can see the slide well enough, and I'm going to blow it up on my screen to give me some idea how well you guys can see it. That graph on the bottom there, you'll see a typical hard drive, and the blue line in every single one of these cases is the speed of the media, okay? And then we've got a little green part there that is the speed of the controller, and another part there that's the speed of the software. Now, there's a little bit here that's not showing up correctly because our graph is a little off, but just plain old, the speed of the media on a hard drive is pretty dang slow compared to these. All of these are flash products. So we're taking a look at a SAS drive, a SATA drive, an NVMe drive. You'll notice when it comes to flash, the speed of the media is the same in all cases. So what do we have to do to be able to take better advantage of that flash-based storage? Well, SAS and SATA, you can see that big yellow bar and that big green bar there. That's what's added by the overhead of having to have a controller and a fairly thick protocol, as both SAS and SATA are. You replace that with NVMe, now we're plugging directly into the PCIe bus, so there is no controller. And on top of that, the actual protocol, the NVMe protocol, is very, very thin. As a matter of fact, day in, day out, there's usually about 3 commands that get used to write or read from NVMe-based products, and that's about it. And this is the protocol that is going to be driving speeds forward for probably the conceivable future until somebody comes up with something better than a PCIe bus, because this is the best way that we can talk to a PCIe bus right now. One of our big stories at Intel is the following line. If you kind of take a look at it at the bottom there, Intel performance is up to 6 times the IOPS of comparing it to these other products. But the big deal is, more importantly than that, more importantly than comparing it to, say, a SAS-based product or a SATA-based flash product, more important is overall Intel products we guarantee are going to operate at 90% consistency of the published specification for that drive. So whatever we publish in terms of IOPS, whatever we publish in terms of latency, you're going to get that throughout the life of the drive, using it at whatever read-write mix that drive is designed for. So to give you a good example, our top-of-the-line products, the P3700 series, for 5 years, you can overwrite that drive 10 times a day. In some cases, some of the products, as much as 17 times a day, the total capacity of the drive. And it will perform 90% consistent with what we published as the specs, regardless of how old the drive is, regardless of how much data you have on the drive, and regardless of how often you're changing data on the drive in terms of that published specification. We know for a fact that there are products on the market, just total transparency here, but if you stick ours in a server and you stick another drive in an identical server and you run them next to each other, straight out of the gate, that other product looks like, wow, that's kind of looks like it's maybe 1% better than the Intel product, and it's a little bit less money. But what we've advised people to do where it's possible is, you know what, let it run. Come back to me and tell me what it looks like when the drive's 10% full or 20% full or 30 or 40 or 50 or when the drive gets older. And almost always people will come back to us and they'll say, wow, we didn't realize how the performance was going to drop off on that other drive. That's a consistent story. And so it's not just a question of how much money you pay for the drive, it's how much money you get for what you're paying for. If you bought a car and they said that car got 40 miles per gallon, and a year later you were getting 10 miles per gallon, you wouldn't think it was a very good deal. And that's kind of the story here, is our published specifications are something that you can count on over the life of the drive. We guarantee that, by the way. If you're not getting that level of performance out of the drive, that's cause for a warranty return, and we will replace the product. Moving forward, everybody's excited about 3D XPoint memory. And 3D XPoint we're now calling Octane. That's our brand name. That's the Intel brand name for this. And conceivably, and this is all kind of theoretically, this is up to 1,000 times faster than NAND. It's definitely up to 1,000 times the endurance of NAND. And it's 10 times denser than DRAM. This is an important story because what it means is that we can get NAND-like densities and DRAM-like speeds out of this new product. Those are going to be coming online later on in the year. The way to get ready for that right now, if you're really, really interested in 3D XPoint or Octane products, is to get into the NVMe stuff. We have found that customers, when they get into the NVMe and the testing that we're doing now with some of our early alpha and beta testing with the Octane product, the customers, the vendors who have all along been working with the NVMe-based product are going to be ready for that Octane product, and all the little things that are built into their code that might be interesting is an interesting word, having to do with switching to NVMe, they get those things worked out, and since the protocol for 3D XPoint and Octane is NVMe as well, they're ready to go. We're already doing testing with StarWind, of course. They've got our NVMe-based products, and they'll eventually get the Octane stuff when it's ready to be sampled at their level, and they'll be ready to go for that reason. The customers that are kind of saying, well, we're on SATA and we're on SAS, we'll wait for this Octane stuff to come out. it's going to be a real big hurdle for you. We're finding in a lot of cases, the vendors that we're working with, they find that like, oh, you know, our code really wasn't optimized for something this fast. Now we have to redo our code to really be able to take advantage of it. So you don't want to be caught waiting like that. So stick with a vendor like StarWind, who's doing this testing and is going to be ahead of the curve, or at least, you know, along with the curve as we move into this new technology. That's all I have. And I'll let Max tell you about all the great stuff about StarWind that uses the Intel SSDs. I'll be hanging around for questions. Emily, I don't know when the question and answer period is, but I'll be here for as long as it takes. Thanks.
Okay, thanks for a great presentation, Alan. And I'll start with a concept or a myth, one more myth about SSDs that swings around the virtualization world and overall IT, that if you are talking all-flash, then you need an all-flash SAN for that. Actually, this concept is only partially right, because making an all-flash SAN, yeah, it's a really good idea. It's a lofty goal to achieve financially maybe, or maybe from the infrastructure standpoint. But if we're looking at typical deployments, we can really avoid an all-flash SAN. So with the picture here, I wanted to show a little find the bottleneck game. You got your new all-flash array at the bottom, and you've got your compute layer on top. And in between, you have all this 1 or 10 gigabit networking, everything wired redundantly, everything's fine. But all those lines, all those network connections are performance bottlenecks. And why do we deploy all flash? Because we want performance. And why do we add a fabric bottleneck here if we want better performance? So StarWind's answer to that is going with local flash instead of keeping flash consolidated in one array or set of arrays. And the main reason for that is latency. With local flash, we're able to access the storage and do IOPS much faster than we could do that with a dedicated SAN. Now, we do see a set of rectangles from left to right showing a typical I/O path for a solution powered by a SAN, like we had on the previous picture here. So the information is transferred from virtual machine to the hypervisor, and then it goes through the HBA, it goes to the network, then it goes to cache on the actual SAN, and only then it's transferred to the SSD. While instead, StarWind uses the fast track for that and grabs the data right after hypervisor tried to put it to initiator and puts it directly into server's RAM, and then puts it on the flash drives. This way we get much higher performance and much lower latency. We're never going to the network for I/O, and we're never even touching the networking stack to do writes for our local running application. That is a huge differentiating factor for hyperconverged environments, and that allows us to really bring the performance to the level where it is expected from flash devices. Now, a little bit of hyperconverged intro here. We've talked about flash options of ours, but for some of you who haven't heard about StarWind's HyperConverged Appliance, it's a solution which allows you to build your IT infrastructure really easy and eliminate any bottlenecks and possible single points of failure in it, all by just buying an appliance which is pre-configured, and as soon as you put it into a rack, it's ready to start your production applications. We put together a big list of vendors who helped us doing this solution and making it a great solution. So we are currently working with Dell sourcing our servers. Our storage, as Alan previously told, is sourced by Intel. After multiple months of investigation, we realized that this is the best option available out there. So next time if someone comes in and says, I want to use those desktop-grade SSDs because they're more affordable, just re-listen to the first part of Alan's presentation, and you'll understand why it is important to put your data on a good SSD, because it deserves to stay alive and not rot under cosmic rays like other vendors may have. Now, we do support VMware and Hyper-V, and we're currently working on KVM support as well. And that also means that with KVM, we'll probably start supporting Zen Server as well. So I'm ready to say that in 1 or 2 months, we'll do support all hypervisors. From the networking standpoint, we really like working with Mellanox. They do deliver really good networking solutions, and that allows us to keep our clusters synchronized fast and with minimum effort and overhead. So that is also a solution which we field tested, and our customers have field tested for almost 5 years already. So it's been a long relationship between our companies. The whole HyperConverged appliance is managed by StarWind, and if you're using vSphere, you'll be using the vCenter. If you're using Hyper-V, there are options. You can go with an old-school Microsoft failover cluster console. You can go with the System Center Virtual Machine Manager if you like, or if you want to have good and lightweight management, you can use Five9 Manager. We work together with Five9 to deliver a joint management console, which includes not only the cluster and hypervisor controls, but also allows you to control the networking, the StarWind storage part, and the backups. So you really have a single pane of glass management here, which allows you to control all elements of the appliance in one place. And one more thing which is peculiar to HyperConverged world is the fact we deliver our appliances with backup options included. Because some people think that if you have HA, you don't need backup, and unfortunately that's totally wrong, because things can go bad in a big scale, and that's when high availability within a single data center is not going to help you. So we are incorporating Veeam Availability Suite in our appliance, and for those scenarios when something goes really, really wrong, we can replicate the entire site to Azure for completing our DR plan. Now, a little bit more about appliances themselves. We do have 2 model lines right now. The L line is 1-unit servers. The minimum cluster is 2 nodes, and that doesn't require any additional back-end networking. So just 2 direct cables can be used to synchronize the appliances together and allow them to work in a cluster. This one delivers up to 16 terabyte of flash storage usable. Then the second model is 2-unit based. It has the same story, 2-node cluster without dedicated networking ready. So you don't need a 40 gigabit switch to incorporate a 40 gigabit synchronization between these hosts. And we're currently working on 100 gigabit networking. So that one would be available shortly for the HyperConverged appliance. And the story will be the same. You can just use a direct 100 gig cable between the appliances and just forget about the fabric inside the cluster. This one can deliver up to almost 40 terabytes of flash storage, And in addition to that, we now support up to 4 additional terabytes of NVMe between these servers. So the virtual machine density for this type of appliance can go up to hundreds of virtual machines per host. And that's something really easy achievable with all flash, especially if flash drives are reliable, which we already know. Now, I told you that there are different management options, and you're probably familiar with vSphere console. You're probably familiar with the StarWind management console, or with System Center Virtual Machine Manager. But I wanted to talk a little bit about 5.9. The management console for 5.9 really delivers a VMware-like experience for a Hyper-V cluster. So the architecture is absolutely simple and easy to understand. So it's that intuitive experience when you're logging on and saying, okay, I've seen it somewhere before, and then you start doing things, and after 1 hour of management, you realize, okay, I've been doing it the same way with the vSphere console for years. So that's a really good and easy way to manage Hyper-V. So we've got the list of the servers on the left, we've got all available actions on the right, and then we have the familiar tabs for us. And 2 more tabs, in addition to the traditional networking, virtual machine, high availability, and stuff like that, feature the backup and feature the storage. So I'll just focus on the backup for this particular slide. So we have incorporated the backup controls in the management console here. So you can not only start and schedule backup jobs, you can also view all the reports from the backup software, as well as control individual jobs and see alarms if something has gone wrong. So it's really an all-in-one single pane of glass management solution, which makes use of the virtualization environment really easy. And with that, I would like to switch over to the questions and answers session, because I know there's a lot of different questions to ask about this solution, and I think we already have a few available.
All right, let's ask some of those questions. Looks like our first question is from Robert. Is this an appliance solution for the hypervisor of your choice with the SSD DAS?
Technically, yes, it is an appliance for the hypervisor you choose. As I mentioned earlier, it's either vSphere or Hyper-V, and we're working on KVM and Xen support as well. And SSDs are all local.
Great. David would like to know, is overprovisioning still an important factor in RAID deployments?
Alan, I think it's a flash-related one. We can answer together. I can do it from StarWind standpoint, and you can do it from the lower level standpoint.
That sounds good.
Okay, so from the StarWind standpoint, we do not do over-provisioning in those deployments, and we're actually working on some features that will allow us to omit RAIDs, hardware RAIDs in our deployments.
From my perspective, it depends upon what part of the system we're talking about. Over-provisioning on the drives themselves, over-provisioning of the flash media is an important technology for ensuring just kind of the basic reliability and performance of the drives themselves. It's maybe not clear, but a lot of times, it's not clear a lot of times, but when you buy a drive that has flash on it and it's rated as a 1.6 terabyte drive, there is likely a heck of a lot more flash actually sitting in that case than 1.6 terabytes. That's one of the ways, because of the way that Flash works, that it's very speedy to write to, or I should say it's very speedy to read from. It's not as speedy to write to, and erasing a block of Flash is a very expensive proposition time-wise. That over-provisioning is the way that the system can keep ahead of all the demands of it. And then there are these little background processes that are really kind of like every individual's vendor's secret sauce as to how they go about reclaiming the Flash that is not now used. So, and then most systems, I know ours do, over time are constantly monitoring themselves to see when do we have a block of Flash that is not really operating consistently, and then we'll mark that one out. So our drives are designed, the amount of over-provisioning, to both ensure the level of performance you want and to make sure that over the life of the drive you have reliable storage and that you have exactly the amount of storage that you bought for and no less.
All right, great. Let's see. Thurston would like to know, is it time to ditch spindles yet for our usual SMD cluster and go for medium-sized SSDs, or still use a mix of spindles and SSDs?
So,
could I answer that one, Max, as the guy who probably
Absolutely.
has the most interest in selling you a bunch of SSDs? We would love it if everybody would go to all flash, of course, because that we're selling the flash, right? The true story is this, and I hate to put it so cagey, but this is really the honest answer, and what you should expect out of any vendor is honesty above everything else. And that is, it depends on your workload. If you've got a bunch of stuff that you store and you only read it and you're not doing a lot of writes and it's not really high performance, then hard drives have a place in the world. And we don't see that like going away tomorrow. However, if what you're looking for is the combination of all the things that flash gives you, the high resiliency, the basic reliability of it, the really, really super speediness, and all of those great aspects, well, then flash is the way to go. So it really does get down to be a question of whether you want performance or whether you want a lot of space, because we have to be honest and say that still, spinning rust on a platter, which is my name for hard drives, still the cost per gigabyte is considerably lower. And for a lot of applications like, let's say, media streaming, in some cases media streaming, if you have just a ton of stuff to store and you're not accessing it all at once, but you still want good performance when you're accessing any one or two particular files, well, hard drives are still a pretty good technology. But we know with working with some of our customers who do this sort of online media streaming and stuff like that, that all of their top tier data and all of their most recently rented and streamed videos, those are all sitting on flash, and in a lot of cases it's our flash for that very reason, both because they don't just need a lot of space, they need space you can use and that they can get to quickly. So I hope that's an answer to your question. That's the best honest answer I can get. And I'm just hoping everybody wants to do high performance things, because that means they're going to buy a lot of our drives. So there.
Well, thank you for that. And I would just add that for environments like you mentioned, when you're doing video, when you've just filmed something and you now need like 10 post-process engineers editing it, you need that video on flash. But when you send it to the movie theater, you're doing tape or you're doing standard hard drive. So it really depends how you access it. Like, for instance, we have a big university in Germany evaluating our solution, and there are just different types of data. There are some active virtual machines which do databases, but there are also lots of reports, old databases which are not being used for current investigations and research, the archive data. And all that cold data belongs to the spinning disks, or another name I've heard today for the spinning disks is low latency tape, but that still has a place in the IT, and I completely agree with Alan.
Great. Let's see. David has a question. What about battery backup? I've seen conflicting reports on the interwebs as to whether it is still important in modern flash deployments.
And the answer is cache is almost unused in the all-flash deployments. As far as I see, majority of RAID vendors say that you are using the RAID card in a pass-through mode with the SSDs. So the battery backup on the RAID is not that important anymore. So what we do instead to accelerate writes and as well as reads is use StarWind distributed caching sitting in DRAM and being synchronized between participating cluster nodes.
Great. Let's see. Jason asks, what are the main management features of StarWind that distinguish it from the peers or competitors?
Okay, so that's an interesting question. I guess from the management standpoint, the ease is the ability to manage it with the minimum hardware footprint behind the cluster. So you're not starting your management with 3 or 4 hosts, but you're actually managing just 2. From the feature standpoint, that varies depending on the management solution between which you choose for the appliance. So basically, if you're using the vSphere console, the management set will be driven by the vSphere console. If you're using the System Center Virtual Machine Manager, you will get all those whopping features of SCVMM. With the joint solution we developed with 5.9, the management is almost at the level of the vSphere console. So I'm not ready to say how we differentiate with exact competitions because there are no exact names listed, but it all depends on the management tools you use. So I know that not using the company names, not to blame anyone or to do head-to-head comparisons here, that some.
Hello?
Max, are you there?
You know, while we're waiting for Max to get back, I was just thinking about Thorsten's question regarding spindles and my answer to it. And I forgot to mention something important, that there are some good rules of thumb in determining that performance versus space equation. And one of them that we kind of use internally, this is not kind of an official thing or something, it's just kind of the way we discuss things sometimes in-house, is we have a thing kind of called the rule of 6. And it is that a single SATA-based flash drive in terms of performance can do about the same throughput as about 6 hard drives that are spinning at 15K. And one NVMe drive can do about the throughput of about 4 to 6 SATA-based flash drives. So that's kind of the breakdown for you. So to equal the performance of a single SATA drive, performance-wise, you'd have to put together a RAID array, probably RAID 0, of 6 SATA-based standard hard drives to equal that level of performance. That's kind of a good way to look at it. So if you're looking at that equation and you're saying, well, that's great, you told me, some information and you really didn't tell me how to make use of it, maybe that's a way to get your head around the problem. And I think Max is back now, so.
Yeah,
Max,
just now back. Yeah, something weird with my phone. Yeah, okay.
Sorry about that.
So, where did you lose me?
In the middle of answering, actually we can move on to the next question. We've got a good one here from Scott. He wants to know if this works well with SimpliVity. Okay, so that's an interesting question because both SimpliVity and StarWind deliver hyperconverged appliances. So if we're doing a comparison between, doing a mixture
of SimpliVity and StarWind, there is a way to do so, but in this case, StarWind will act as a dedicated storage for SimpliVity. Or if you're talking about using Intel drives in SimpliVity, that may be a different question. So, Scott, if you could please specify, are you talking about the drives or about the solution as such? That would be really helpful.
All right, great. Scott, if you can give us some clarification, we'll answer the rest of your questions. Robert would like to know, can these be deployed as a drop-in host in an existing VMware deployment?
Absolutely. We do support that, and for best results, it's better to deploy 2 hosts so you can start using the highly available storage, but we also support just dropping in 1 host as long as you mirror the storage with something in your existing environment.
Great. Robert asks, what's the difference in purchasing a Dell server with SSD DAS opposed to this solution?
The main difference is that if you purchase a Dell with SSD DAS, you're just getting a server. You still need to get a hypervisor, you still need to get a shared storage solution, and you still need to get all those components I previously mentioned. In case of StarWind's HyperConverged Appliance, you're getting a pre-built ready node with the hypervisor installed, with StarWind already configured and all your storage already set up in a highly available manner. And on top of that, we do support that entire solution from the SSD up to the virtual machine. So if anything happens to it, we will be the one to call, and we will be the one to fix the entire solution.
Great. Brandon would like to know, do SSDs nowadays last as long as HDDs?
I think that's for me. We partly dealt with this at the beginning of the presentation, and I apologize if I was not very clear in the way that I explained it. Right now, today, everybody's flash drives that are on the market, I should say any major player, because God knows what you're going to find on eBay or from some company that just started up, are about 10 times more reliable than hard drives. And that's a fact. We see that over and over in the industry. Ours are about 20 times more reliable. Now, when we say that, we're saying things like at a particular rate of usage over time. So just as a general reliability issue, SATA and NVMe-based SSDs, considerably more reliable. I hope that answers your question. I think that some of what I'm hearing is in that question that's maybe unspoken is with SSDs, the technology is mysterious and people don't necessarily always understand how it works. So there's a built-in kind of questioning of anything that you don't understand, whereas we kind of all understand what a hard drive is. It's basically like a tape recorder, but on a disk instead of a tape, if you want to look at it that way. They wear differently. They experience different patterns of wear. We do put a lot of tools into our systems that are available for you that if you want to, in an employed environment and an installed environment, you can actually predict when your drives are going to go bad to a very, very high degree of accuracy. We offer tools for that will constantly monitor, if you want to, your flash memory, and it'll say, on about October 30th of 2022, this drive needs to be replaced. And believe me, you really ought to be looking to replace that about October 15th, because right in there somewhere, that tool is very accurate about telling you when the performance of that drive is going to degrade or whether you're going to start losing space or things like that. With hard drives, it's always been a little bit more random. We have things like smart tools that let us give us some insight into how the drive is performing, but not nearly so predictively. So that's probably more information than you asked for. I have the tendency to ramble on when I've got a lot of coffee in me, but hopefully that answers the question.
All right. So Scott came back and clarified and said, I was looking more into the solution. I think he answered it as an either-or solution. So with SimpliVity, it's just storage. Without it, it's the same as SimpliVity. Can you confirm or deny?
Yeah, I actually had a second thought about it, and I guess ultimately it's going to be a mixed cluster of StarWind and SimpliVity, all running hypervisor, all sharing storage between themselves, and all running the applications inside virtual machines. So that kind of setup will be supported. The only disclaimer I have to make, we'll probably need to do two different storage pools, one's owned by SimpliVity and one's owned by StarWind. But altogether, that can work as one big cluster.
All right, let's see. Tommy wants to know how is the interfacing to an equal logic box?
Okay, if you want to attach an equal logic to StarWind's HyperConverged Appliance, that can definitely be done, and that will be just standard iSCSI. We do support that. If your equal logic is a filer, then you can do that using NFS for VMware or SMB. I'm not sure if equal logic supports SMB, but in any case, you can provide equal logic storage to the StarWind appliance. That is still supported.
Max, that would be an interesting idea. That one of the cases where you've got not only a mixture of storage technologies, but a mixture of the software that's running it. Attaching something like that with a lot of spinners to it could provide a really good warm or cold data area at a good price, where all of your management software and all the stuff that StarWind brings to bringing that stuff onto the network in a very easy way could provide a hot tier as well as management capabilities over the top of it.
Yeah, and there is even more than that. So we recently released our new storage appliance. So right now we talked about HyperConverged Appliance, but there is also a storage appliance for all those environments where your compute needs to be separate. And what we did a special design where we have one full flash node, and that full flash node is mirrored with a spinning disk node. So the idea behind it is that customer data is always stored in flash. It's not tiered down to the spinning rust, but the second copy of the data is stored on the accelerated spindles. So if something goes wrong with the flash node, you can still use the second copy of the data. And the price tag is much more affordable than, let's say, having two nodes, each having 40 terabytes of flash. So that is an interesting concept, and if you like, we'll be doing a webinar on it shortly, so stay tuned for more information.
All right, fantastic. So we are out of questions, but I do want to ask, Max, where can our audience learn more about this product, these services, find out about pricing, look into learning more about implementing this in their own system? Can you tell our site heads where they should go?
Absolutely, absolutely. So first of all, we do see that lots of folks, even though they know our website and they know lots of our contacts, they still go to Spiceworks and ask their storage-related or virtualization-related questions on Spiceworks. And keep up the good job, guys. You're making the community live. But if you really want to talk with StarWind representatives on the phone and not in the community, we're available at starwind.com. sales@starwind.com, or if you want to ask something personally, my email address is really easy. It's max@starwind.com. I'll be glad to help you with any questions you might have.
If you've got any questions specifically related to our SSD products or NVMe products, anything like that, you can email me directly at william.a.shear@intel.com. I'm tempted to actually give out my cell phone number, but that never turns out right. So william.a.shear@intel.com, and I'd be happy to either answer your questions directly or get you in touch with somebody a lot more nerdy and geeky who could probably drill down as far as you want to go on it.
All right, fantastic. Thank you for that awesome presentation. Hopefully everybody was able to learn a bit more. I do want to remind everyone that if your question wasn't addressed, somebody from StarWind or Intel will be able to follow up with you. And if you had to step out or miss any part of today's presentation, you will be receiving an email in a few days with a link to view the webinar on demand. Special thanks to both StarWind and Intel for creating today's content and sponsoring this great event. And thanks to each and every one of you for tuning in today. We hope to see you back soon for another SpiceWorks Partner webinar. Until then, stay safe and keep it spicy.